Hey guys, this is lesson 1.5 and 1.6 combined actually, which I think for you guys means that this is Friday, September 25th. So you have a quick warm up here. Certainly pause the videos um, and get your answers and then resume it once you got them. All right, so the slope for this one, you should get 8 minus 2, which is 6, over 15 minus 7, which is 8. So 6/8 should be 3/4. And that should take care of that answer. The next one, you would have find the zeros using a graphing calculator, which I think if you did it, you'd get x equals negative 1.37, 0.37, and 1. I think 1 actually works by itself. So those would be your three zeros. Again, it's a degree of 3, so you're looking for three zeros. Whether it's a double root maybe in one other one, um, which means it's a point of tangency, or you could have two imaginary roots too, but not with that one. All right, so 1.5 is very easy. I think it's kind of a slow lesson, but it's increasing, decreasing, and constant intervals, and that's kind of what we're looking at. So you'll see that there are a bunch. Like this first one has a decreasing interval, a constant interval, and an increasing interval, right? So anywhere, this is kind of confusing language, but it does make sense, right? If it's increasing, if between any two x values, right, x1 coming first, x2 coming later, if the y values, are getting smaller, like this, right? Y is getting smaller here to here. That's a decreasing interval, right? Um, Here it says f of x1 is less than, so that means actually getting bigger. Sorry, should have looked at this one. Right, this y and this y, this one's getting bigger, so it's increasing. That's really all it's saying. This one, f1 is bigger than f of x2, so that means the y is getting smaller. Constant is when the y values equal each other. So right here, we would say that, sorry, right here in this first part, we would say that it's decreasing from negative 2 to 0, right? These are just the x values that we're giving. And then it's constant from 0 to 2. Actually, and we're going to use parentheses here. I shouldn't use brackets. Even though it's included, you can just always use parentheses for increasing, decreasing, and constant. And then it's increasing from 2, not to infinity. It looks like it stops right there at 4, right? So you would just want to label these as, right here I'll just do it. Increasing for this one, and then 2 to 4, constant, 0 to 2, and decreasing from negative 2 to 0, right? Pretty basic. So like this one, this is f of x equals x to the third, right? If you look at it, this is always increasing. It looks like it does level out for a second, but not completely, right? So this is literally, we would say, increasing. Let me get it here. Increasing, and we would say negative infinity to infinity, right? The whole time it's increasing. So if you had to put decreasing, you would just kind of give me one of those, right? It doesn't exist. There's no decreasing intervals. The whole thing is increasing the whole time. This one, increasing up until here, then it starts decreasing, and then it starts increasing again, right? This point right here, we want to know what it means. It's called a relative maximum, right? So we got relative maximum. It's not the maximum for the whole graph. The maximum for the whole graph is infinity, right? This point's going to go up to infinity. And then right here, at 1 comma negative 2, we're going to have what's called a relative minimum. You can also hear it called a local minimum or local maximum. It's the same thing. You can get them on your calculator by going left bound, right bound, just like you would a vertex for a quadratic, right? Same exact stuff. So we would say here, right, we have a graph that is increasing. I'm not on the marker. Right, so I'm going to say it's increasing. And where is it increasing from? Well, it's increasing from negative infinity until we hit that relative maximum, which again, we only want the x coordinates here, so until -1. And then in union with, right, because it's increasing again from 1 to infinity. So that's everywhere where the graph is going up from left to right. So that means decreasing would be where it's going down, and it's basically the other spots, right? So that's from -1 to 1. Again, the y coordinates are not important when you're labeling increasing and decreasing. It's just the x coordinates, and that is it. So that takes care of that one. There's no constant intervals, so you don't have to worry about it. This one I want you to just do on your own really quickly. And so pause the video and then kind of resume it when you're done. All right, so for this one, we should have had increasing. Man, this is really not ideal. Okay, so we have increasing, and you can see it's definitely increasing from negative infinity, right? We're going up, and it's going up, 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 up until we hit x equals 0. So the 1's not important, we just want 0. And that's it, right? There's no other parts where the graph is going up. So then we're going to look at, okay, well, decreasing then. And that's going to be from x equals 2, and then that line's going for infinity, so it's going to be 2 to infinity. And then constant would be the rest. And constant's going to be from 0 to 2. Right? So as you look at these, make sure that every x is covered, right? You got negative infinity to 0 for increasing. Then you got 0 to 2, and then you get 2 to infinity. That's everything, right? The graph's going to be doing something somewhere along the way, unless you don't have a domain there, in which case that may happen. But you can double check these really quickly. So relative minimums and maximums, I've already talked about it, right? Again, they're not the total maximum or minimum necessarily. They're just kind of, in relation to where it stops increasing and stops decreasing. So typical problem would be something like this: find minimums, maximums, intervals of increasing and decreasing, and zeros. So go ahead and on your graphing calculator do this one, and then I'll just give you the answers. All right, so if you did this, the local maximum, you should have gotten negative 2.16, 11.08. The local minimum, you should have gotten positive 2.16, negative 9.08. And then increasing, you're going to use just these x coordinates. You don't need the y's. But the increasing, you should have negative infinity to negative 2.16 in union with positive 2.16 to infinity. And then decreasing just in between, negative 2.16, comma 2.16. Right? Always parentheses. And then your zeros, 3.67, 0.14, negative 3.81. And that is it. I do have this to show you how increasing and decreasing does actually happen, but apparently the video is private. But I think if we just search line birds, we'll get something.
Do you want to smoke? No, I don't think so.
I don't think so.
I can't separate my index finger from my middle finger, so use your other hand. I'm not breaking up, death maggot!
Wow.
With a toxic mix of over 7,000 chemicals, any reason is a brilliant reason not to smoke. Share yours.
Hey guys,
there you
this
go.
app review is going to be on the amazing game that has... Alright, let's open up. But once you get to the main screen, you can have play, medium, and hard. Trying to tap on Bluebird, I think he has the ability to...
Right, so this, sorry about the ad there. Right, but you can kind of see it, right? This bird is like, it's basically math is behind it. It's just this giant polynomial, right? Where you're increasing, decreasing, increasing, decreasing, and the timing of it, right? Where you have those local minimums and maximums kind of decides if you're able to, keep going, I guess. But, just trying to show you an example in the real world of how these things work. Right. And that's pretty much it for 1.5, and we're just going to roll right into 1.6. So you have a warm-up here. Again, you should have, the notes. Hopefully you got those already. You didn't need a ton, but you should have these in front of you. They're on Schoology, but I think I printed them out. You can check the corner. There was nothing for 1.5, but 1.6 does have this stuff. And actually, I don't think I posted it. It's something that you can, I don't think I made copies. You can check. I think everything's right here, though. So, going through the notes. Do this really quick warm-up, and then we'll go over it so you can pause the video. All right, so I have f of 2. If I look at f of 2, right, what does that try and say? Well, this is f of x. So if I look at where x is equal to 2, you get negative 1. So f of 2 is negative 1. Right? F of 4 is where the x coordinate is equal to 4 within f of x. So when I plug in 4, right, I get 5. So f of 4 is 5. If I look at g of f of 3, kind of more the same, right? First thing you want to do is the one on the inside. So f of 3, okay, well if I plug in 3, I get 3. So what it really wants is g of 3, right? Because f of 3 was 3. What's g of 3? Well, this is an equation, not a graph, right? So you're going to plug in 3 for x. So you're going to get 5 over 3 times 3 plus 1, which is going to be 5 over 10, which is 1/2. And g of f of 4, right? Well, f of 4 was 5. So again, it's just asking me for g of 5. And this is kind of composites that we did last year. Plugging in 5, I get 5 over 3 times 5, which is 15, plus 1 is 16. So I get 5/16. Right. So again, composites, a little bit more operations. We'll do some more composites next class. Right. So operations of functions is 1.6 part 1. Actually, part 2 is compositions. It's before next class. So if I said, f plus g of x is kind of what I would want to do. So the first one, we're going to say it's going to be f plus g of x, right? And all that's saying is, since it's the entire f of x plus the entire g of x, literally just add these two together. So you probably put these in parentheses too. But what it's saying is it's the sum of f and g, so it's f plus g of x. Take f of x's, x plus 1, add g of x's, x squared minus 1, and just add them all together. So you should get something like x squared, right, from the x squared, plus this x. I'm just writing it in descending order. And then positive 1 and negative 1 cancel, so you're just going to get x squared plus x. You don't need to do anything to that, factor it. No, you don't need to. Number 2 is the difference. So if it's saying the difference of f and g, take f of x and subtract g of x. So it's f minus g of x. And this one's a little bit different. Well, pretty straightforward though. You're going to take x minus 1, since that's f of x, and you're just going to subtract x squared minus 1. And when you do it this way, right, you're going to get negative x squared is going to be the first term. And then x is going to be the next term, right? There's nothing else to subtract with the x. And then negative 1 minus negative 1. I'm sorry, this was x plus 1, that's why. 1 minus negative 1 is 1 plus 1, so you're going to get plus 2. Now, keep in mind, when you're adding the two, g plus f of x is the exact same thing as f plus g of x. It doesn't matter what order you do them, but subtracting it would be a difference. If I said g minus f of x and flip-flop these around, you'd get a different answer, right? 5 plus 2 is 7. 2 plus 5 is 7. That doesn't make a difference. But 5 minus 2 is 3, but 2 minus 5 is a different number. It's negative 3, right? So this one order does matter when you're subtracting. Multiplication is next. That's the product. This one does not matter. It's just like addition. So if we wanted to multiply the two together, you're pretty much just going to FOIL. So you would have x plus 1 and then times x squared minus 1, right? And you can go ahead and FOIL. I know you guys know how to do that. Your final answer should be x to the third plus x squared minus x minus 1. Right? That's what you get when you FOIL. And then the fourth one is the quotient. Again, order does matter here. So it's f divided by g of x like this. It's the same thing as f of x over g of x. And this is the one that's probably going to require the most work sometimes. Multiplication might be. But f of x is going to be x plus 1. And then g of x is x squared minus 1. However, you always want to look, that's not done yet, right? Because you can break up x squared minus 1 into x plus 1 and x minus 1, in which case these are going to cancel. You're going to get this is equal to 1 over x minus 1. And if you guys remember me last year, we would want to say also x cannot equal positive 1. I'm sorry, x cannot equal negative 1. We know x cannot equal positive 1 because if you plugged in positive 1 right there, you'd get 0. But it also can't equal negative 1. And you might say, well, why? Because negative 1 minus 1 is negative 2. What's the big deal? But if you think about the original, which was x squared minus 1, when you plug in negative 1, you get 0 in the denominator. So you want to include that in there and just say, okay, well, x cannot equal negative 1 either. Because if you have negative 1, if you look at the original, it doesn't work. So that would be the entire answer. Okay? All right, so those are operations. And then the back side of that worksheet that I just showed, which I'm not sure you have or not, are just compositions, which again we've done before. So we have f of g of x, meaning you're plugging in the entire g of x for that x, right? So it's, you get something like, plugging in this into the entire x. So it's going to be 2x minus 3 plus 1, and then you'd simplify it to 2x minus 2. You do it the other way around. You're plugging in the entire f of x into that x here, which is what you see here, 2 times x plus 1, and then minus 3. Distribute it out, you're going to get 2x minus 1, right? Now here's the only thing. The domain of the innermost function must always be part of the final domain. So here, we'll just look at this one. It seems pretty simple, right? So if I have, f of x equals the square root of x, and g of x equals x squared. And I said find g of f of x. So I'm plugging in f of x into the g of x equation. Well, what does that mean? It means I should have, instead of x squared, I would have the square root of x, all squared, right? I just plugged in the f of x, square root of x, into the g of x equation. And you would want to say, okay, well, that just equals x, right? The square root of x squared is just x. However, if I ever ask you for the domain, right, you would have to say it's only from 0 to infinity. And you might say, well, why? If you say, f of x equals x, or g of f of x equals x, you can plug in whatever you want for x. It's your identity function. Why do you have to restrict it to 0 to infinity? And I would say, well, because if you look at this, you could have only plugged in numbers from 0 to infinity. You couldn't have plugged in negatives to start. As a result, you squared it. But you don't want to ever deal with imaginary numbers with this. So your domain is restricted, 0 to infinity, even though your final outcome looks like it's fine. All right, the last type of question that we'll have, and it's going to be writing something in terms of another. It's really just composites. So if I said, write j in terms of a, and I said j of x, or j is equal to x squared, and 0.5a is equal to 2x, what the heck does that mean? Well, it just means, basically, j in terms of a, right? I want to do like f of x almost, but I'm just going to do j of a. And I got to figure out what that is equal to. So instead of an x in there, I have an a. So what happens is I need to turn around this equation so that I can get x equal to something, in which case I can replace it here. So what I want to do is kind of get x by itself. So I'm going to divide both sides by 2. So I'm going to get something like 1/4 a, right? 0.5 divided by 2. Same thing as 1/2 times 1/2. So I'm going to get 1/4 a is equal to x. And that's good. Right now, instead of saying x here, I can say 1/4 a. So I'm going to keep going here, and I'm going to say j is equal to not x squared, but 1/4 a squared. So 1/4 a, and then all squared, right? So what I've done is now I don't have any x's, which is good because I wanted to write j in terms of a. So those are the only two letters I want here. So then I would say j in terms of a is going to be 1/16 a squared. Or a squared over 16 is probably better, but same thing, right? And that would be your answer. So on your own, just write g in terms of b. If g is x over 5 and b squared is equal to x plus 1, pause the video when you have an answer. All right, so for this one, you should have gotten g in terms of b is equal to b squared minus 1 over 5. Again, kind of the same thing. You'd want to try and get this x by itself. So you get b squared minus 1, plug it into this x. So now you have g in terms of b. There's no more x's, right? So what I want you to do now is with that worksheet that I had out, all you're going to do is the classwork and homework sections on 1.6 parts 1 and 2. Right, so 1.6 parts 1 and 2. There's the first part. Make sure you don't overlook that one. 89, 5 through 23 odds. And then, this is kind of the same notes that I did. You can certainly look through them, though, if you're a little bit unsure. And then do this. So you have two parts, one on each page. One's dealing with operations. One's dealing with compositions. And I believe that's it. But certainly check Schoology to make sure that that is it. Okay, thanks.